Plastic die molds are the unsung heroes of manufacturing. These precision tools create a wide variety of plastic products we use daily. From medical devices to toys, they are the backbone of modern manufacturing. Imagine a mold as a cookie cutter, but instead of dough, we use molten plastic. The process involves injecting molten plastic into a mold cavity, cooling, and ejecting the solidified part. This seemingly simple process requires a complex interplay of design, engineering, and precision machining. Without plastic die molds, our world would be very different. The journey of creating a plastic part begins with a vision. This vision is translated into a detailed design using CAD software. Think of CAD software as a digital sculptor's toolkit, creating intricate three-dimensional models. This digital model serves as the blueprint for the entire mold-making process. Every detail is meticulously defined, ensuring the final plastic part is flawless. Skilled engineers work tirelessly to perfect this digital blueprint. The mold base is the foundation upon which the entire mold is built. It serves as the backbone, providing the necessary support and alignment for the mold components. Without a solid and well-chosen mold base, the integrity and precision of the final product can be compromised. The choice of material for the mold base depends on several critical factors. These include the type of plastic being molded, the complexity of the part design, and the expected production volume. For instance, if the plastic material is abrasive or the part design is intricate, a more durable mold-based material might be required. Steel is a common choice for mold bases due to its exceptional strength and durability. It can withstand high pressures and temperatures, making it ideal for long production runs and complex molds. On the other hand, aluminum is favored for its lightweight properties and excellent thermal conductivity. This makes it suitable for prototypes and short production runs where quick heat dissipation is crucial. The mold base is precisely machined to the exact dimensions specified in the digital design. This precision is crucial to ensure that all components fit together perfectly and function as intended. Creating a mold base involves using specialized cutting tools to carve out spaces for the cavity, core, and cooling channels. These features are essential for the molding process, as they help shape the final product and manage the heat generated during molding. Skilled machinists and advanced CNC machines play a vital role in this process. Their expertise and precision ensure that the mold base is crafted to perfection, providing a reliable foundation for the plastic die mold. This meticulous attention to detail is what ultimately leads to high-quality, consistent production outcomes. With the mold base ready, the next step is to create the cavity and core. The cavity gives the plastic part its external shape, while the core forms the internal surfaces. Machining the cavity and core demands specialized tools and techniques. For intricate designs, electrical discharge machining, EDM, is often used. EDM uses electrical sparks to erode material with extreme accuracy. This precision ensures the final plastic part has the desired shape, size, and surface finish. Cooling plays a vital role in plastic injection molding. As molten plastic cools, it tends to shrink, which can lead to warpage or defects. Cooling channels circulate a fluid to regulate the mold's temperature. These channels ensure even cooling, preventing defects like sink marks or warping. Engineers carefully calculate the optimal layout and size of cooling channels. This ensures high-quality, dimensionally stable parts. Once the plastic has cooled, it's time to release the part from the mold. This is a crucial phase in the mold design process, as the integrity of the final product depends on how well this step is executed. The cooling process solidifies the plastic, making it ready for the next stage. The ejection system ensures the part is removed smoothly and without damage. This system is meticulously designed to handle the part delicately, preventing any potential defects that could arise from improper ejection. The efficiency of the ejection system is paramount to maintaining the quality of the molded part. Ejector pins, small cylindrical pins, gently push the part out of the mold. These pins are strategically placed to apply uniform pressure, ensuring the part is released without any warping or deformation. The precision of the ejector pin's movement is a testament to the detailed engineering involved in mold design. For complex parts, Stripper plates may be used to strip the part away from the mold. Stripper plates are particularly useful for parts with intricate designs or undercuts that make them difficult to eject using pins alone. They provide an additional layer of support, ensuring the part is released cleanly and efficiently. The design and placement of ejector pins and stripper plates are critical. Engineers must carefully consider the geometry of the part and the mold to determine the optimal locations for these components. Proper placement ensures that the ejection process is smooth and that the part maintains its intended shape and dimensions. They ensure the part is ejected evenly without applying excessive force. Even distribution of force is essential to prevent stress concentrations that could lead to cracks or other defects. The goal is to achieve a seamless release that preserves the quality and functionality of the part. This careful planning ensures the efficient and damage-free release of each molded part. Every aspect of the ejection system, from the type of pins used to the timing of their activation, is meticulously planned and tested. This attention to detail is what makes the difference between a high-quality product and one that fails to meet standards. The success of the mold design process hinges on these vital steps, ensuring that each part is produced to perfection. With all components crafted, it's time to assemble the mold. The assembly process begins by fitting the cavity and core inserts into the mold base. These inserts are precisely aligned and secured, ensuring a sealed cavity for the molten plastic. Cooling channels are connected to the external plumbing system. The ejection system is integrated with ejector pins or stripper plates aligned and connected. Skilled technicians ensure every component is perfectly aligned and securely fastened. The mold's surface finish plays a crucial role in the final part's appearance and functionality. A well-polished mold ensures that the plastic part produced is smooth, free of defects, and meets the desired specifications. The quality of the mold surface directly impacts the efficiency of the production process and the overall quality of the final product. A rough surface can result in blemishes or difficulty in ejecting the part. These imperfections can lead to increased production time and higher rejection rates, ultimately affecting the cost and efficiency of manufacturing. Ensuring a smooth mold surface is essential to avoid these issues and to produce high-quality parts consistently. The mold undergoes a meticulous polishing process to achieve the desired surface quality. This process involves several stages, each using different tools and techniques to gradually refine the surface. Skilled technicians carefully polish the mold, paying close attention to every detail to ensure a flawless finish. Polishing starts with coarser grits, progressing to finer grits for a mirror-like finish. This step-by-step approach ensures that any initial roughness is smoothed out and the surface becomes progressively finer. The final stages of polishing use extremely fine abrasives to achieve a high-gloss, mirror-like finish that is essential for certain applications. Textures can be added to create specific patterns or finishes on the plastic part. These textures can range from simple matte finishes to complex patterns that enhance the aesthetic appeal or functionality of the part. The choice of texture depends on the intended use of the part and the desired visual effect. Methods like laser etching or chemical etching are used for texturing. Laser etching allows for precise and intricate designs, while chemical etching can create uniform textures over larger areas. Both methods offer unique advantages and can be selected based on the specific requirements of the project. The mold's finishing touches are crucial for the final plastic part's aesthetic and functional qualities. A thorough inspection ensures that the mold meets all specifications and that the surface finish is perfect. The comparison between the polished mold and the finished plastic part highlights the importance of this process in achieving high-quality results. The attention to detail in mold finishing ultimately leads to better performance, durability, and appearance of the final product. Before mass production, the mold undergoes rigorous testing. This step identifies and rectifies any potential issues. The testing process involves running the mold on an injection molding machine. Engineers inspect the molded parts for defects and monitor the cooling and ejection systems. If issues are detected, the mold is modified and retested. This meticulous approach ensures the final mold is optimized for efficient production. Once the mold passes all tests, It undergoes a final hardening and finishing process. Hardening involves heat treating the mold to increase its hardness and wear resistance. The mold might undergo additional surface treatments to enhance durability. Wear-resistant coatings reduce friction and prevent material buildup. The mold undergoes a thorough cleaning and inspection process. The mold is now ready for mass production. Plastic die molds are the unsung heroes of our modern world. These tools shape countless aspects of our lives, from cars to medical devices. The journey of crafting a plastic die mold is a testament to human ingenuity. Every step demands precision, expertise, and a deep understanding of materials. As demand for plastic products increases, plastic die molds will continue to evolve. Behind every plastic product lies a complex world of engineering and manufacturing, orchestrated by the plastic die mold.